Hi everyone. So today we will be discussing about three topics. So the first one would be what are the networks and what is internet, and then we'll be discussing how the devices or machines are identified on a network. So what kind of mechanism it follows to find out uh, which machine is being used to send messages to another machine and things like that. And then if time allows, then we'll be also discussing about the ping uh, utility that comes out of the box with Windows and Linux operating system as well. So we'll be going through that part in case we have enough time today. So let's start. We'll be referring to one of the TryHackMe room. So you can access it by clicking on learn, and then under the search section you have to search for network. And today we'll be going through this particular room, that is what is networking. So in case you guys want to watch this already existing networking video by TryHackMe itself, you can do so. Otherwise, we'll be just going through this part quickly, and I will try my best to explain whatever is written here. So first of all, what is networking? So networking, when we talk about networking, it means that um, the networks are being used to communicate with each other, and that whole process actually is called as networking. Now, in like if we try to understand what are networks, so networks could be anything. Like here, there are a few examples. Networks could be like five friends are there, right? So that's a internal network of five people. Similarly, we have neighbors, right? So that is also kind of a network you can call. Also, when we talk about postal systems, um, to send letters and parcels, so there also there is a huge network that is managing all these kind of facility, that someone is like you are sending a letter and then postman is picking it up and then delivering it to the next person. So all these, like wherever you see things connected, you can say it's kind of a network. Okay, now here also you can see an example that Bob is sending uh, uh, you can say it's post mail or email as well. So he's sending it to Alice, and then Alice is sending it to Jim, and back and forth. So now, because all these people are sending or like communicating with each other, so you can say it's kind of a network between these three people. Okay, so that's what it is. And we are not going to cover try to complete these question and answers right now. We'll do it maybe tomorrow. So that's what a network is normally. Okay, now if we talk about internet, okay, so internet actually means that a combination of different networks. Okay, for example, earlier we had only three people. Now if we add Zan and Toby as well, and like this is a small network, now a lot of people get connected to each other. Like right now when we say internet, we have like millions of networks that are connected with each other, and you can send an email from a person can send an email from any place to anyone else on the internet. Like that person could be in any part of the world. So it's possible because all the networks from different locations are connected with each other. So that's what it is. And here there is some details how internet started it in 1960s as a ARPANET project, and earlier it was only used by United States Defense Department and things like that. But later on it was converted into World Wide Web that we know now, www. And now when that got introduced, we got introduced about www, then the internet got a bit famous, and then it was being used by a lot of people to communicate with each other. So this is, in simpler words, you can say, suppose there are two computers, okay, and this is a router. Okay, router, like both these computers, if they are trying to send a message to the internet or like to another person who is not in their network, that message will be sent to a router will forward it to the internet. Now its internet is not like a cloud, but it's a mix of these routers and switches and all these things only. Okay, so internet is made of those you can say small networks as well. Now you can see that using this internet, all these three networks are connected with each other. So you can say combination of a lot of networks uh, globally is right now called as a internet only. So yeah, now we will discuss a bit about a private network, okay, and a public network as well. So, uh, the best example for a private network is at your home when uh, you are using your Wi-Fi and all of you are connected to the Wi-Fi right now, and that is actually a private network. Even if there is no internet connection, okay, even if there is what you say, even if yeah, the internet is down, okay, still what you would be able to do is uh, whatever devices are connected under that particular Wi-Fi, you would be able to you would be able to uh, share data within that network. How, like, we have nowadays we have different mobile apps, right? Share it and like that. So if you are connected to the Wi-Fi, even though there is no internet, still whatever devices are connected with that Wi-Fi, you would be able to share data over Wi-Fi without any need of the internet, because you have that share it and all these apps, these works on the private network only. You are able to share data from your mobile to your laptop or mobile to mobile, all these kind of things. So that is an example of a private network. Now if we talk about a public network, suppose now if we are connected to the internet, our Wi-Fi is working with the internet, and if you want to send an email to someone who is not at your location, who is in a different country, okay, or in a different city, or like connected to a different Wi-Fi actually, not your Wi-Fi. Now if you want to send an email or send a message like WhatsApp or Facebook, Instagram, whatever you want to do, if you want to send a message, then you have to connect with the public network, and public network normally we call as internet only. So for public network to work, you have to be connected with the internet. So whenever you are using the internet, you can say you are using the public network, because when we say public, it means we are connected to everyone else on the internet. And using public networks, you would be able to send messages to anyone who is connected to the internet. You won't be able to send messages to those who are not connected to the internet, or who are only in the private network. Okay, so those people you won't be able to message, but whoever is connected to the internet, you would be able to send messages. So that is the public network. Now let's move on to the third part. Here we have how we identify devices on a particular network. For example, in at your home only, in the Wi-Fi, or earlier we used to have LAN connection, local area networks. So they are all like, we used to plug in cables in laptops and computers, and that way we used to be connected within a private network only. But now you can say Wi-Fi without internet is a private network only. So within a Wi-Fi network, how one device is able to identify the other device? Okay, like even if 10 devices are connected to the same Wi-Fi, so how one like a person is able to send a message to a particular person only, not everyone else on that network. So how these devices are identified on the network, we will be discussing it. So you can understand it by, like, devices are like humans only. Humans have names and fingerprints. Similarly, devices are assigned a IP address, okay, and a MAC address as well. Okay, so IP address, what is IP address? We have discussed a little bit about IP addresses in previous sessions, where we just understood that IP address is nothing but a numeric number that is assigned to a particular device, and it is going to be a unique number. Okay, so suppose if I try to explain it here, suppose uh, we have this is our Wi-Fi, and we are connected to this Wi-Fi. Okay, so let's see. Yeah, Suppose this is our Wi-Fi, and then there are different machines under the same Wi-Fi that are connected with it. So that could be anything. So just a moment. So suppose we have these are connected like this with this Wi-Fi, and now if this particular machine or laptop or whatever you want to call it, okay, or mobile as well, if this one is trying to send a message to this particular machine right here, okay, how is this machine able to send the message to this one only and not the others? So that's what we are going to discuss. So every machine in a private network, okay, that will be assigned a IP and a MAC address as well. Okay, now let's discuss a bit about IP first, and then we'll be moving on to the MAC addresses. So IP address is nothing but a unique number assigned to it. Okay, this is what a IP address looks like. It is separated by three dots, and there are four octets. Okay, one part is octet 1, this is octet 2, third one is octet 3, fourth is octet 4, and every one of these parts, okay, the possible values could be 0 to 255, means every place can have 256 values. Okay, instead of 192 we could have 0 or 1. Okay, similarly with the second octet as well, the possible values are 0 to 255. Same goes for octet 3, octet 4. So now if we talk about how many possible IPs there could be in the whole world, so every place could have from 0 to 255, that means around 256. So let's use calculator, and so the number of IPs that are possible, like all the combination of IPs, that is around this much. So these many IPs are valid IPs in the whole world. If we talk about IPv4, there is a version only IPv4. Okay, version 4 of IPs. So these many IPs are only available to be assigned to different people. Now out of these IPs, okay, out of these IPs, few IPs are there to be used in private networks. We have already discussed about private networks, and then rest of the IPs are available to be used as a public IP address. We will be discussing it in more detail in upcoming sessions, but right now we are focusing on what are the IP addresses. So private IP and public IPs we will be discussing later on. I will be showing you what are the ranges for private IPs and public IPs. But for the time being, let's discuss about the IP addresses only. So IP addresses looks like this, okay, and it will be unique in a private network. Okay, for example, if the we have 5 machines in our internal Wi-Fi, right, or private network, every machine is going to have a different IP. Okay, two machines can't have a same IP because it has to be unique. If two machines become like are having a same IP, that means how are we going to identify where to send a message or from where to get the data? So that's why if this one is having IP, for example, I will put it like 192.168.1.2, then this one has to be it has to be have a different IP, different from 1.2. So it could be 1.5 or it could be anything, but it can't be 1.2. Okay, so that's how the IPs are assigned. IPs has to be unique within a network. So like that, similarly these will be assigned to other devices as well. So that's what IPs are. And here there is an example given, that there is a desktop computer, okay, with a name something like this. Okay, the same name is here, and for that machine the private IP is this. Okay, we'll discuss how you can identify based on the IP address syntax only whether it's in private IP or public IP. We'll discuss that later on, but here it is given that it is a private IP. Okay, so just focus on that part as of now. And then for the same machine, IP is given that is public. Okay, so what it means? Okay, it means that a machine can have a private IP and a public IP as well. Private IP will be utilized whenever it is uh, talking to other computers or other devices in the same network. Okay, like in the private network, whenever it is talking, it will be using private IP. Okay, but now if we want to connect this Wi-Fi to the internet, okay, and suppose we have internet right here, and from that internet there is a different machine or a different network altogether. So suppose this is a different machine, like in different country. Okay, so that's a completely different network. So now if I'm what I try to do is, if I try to send a message from this particular computer to this computer that is in a different country, right, like from here to this one, what I need to do, I have to go through the Wi-Fi, then I have to get connected to the internet, and then internet will forward my request to that another computer in the different network, and that then it is going to respond back. It will come the same way from how we reached out to it. So again it will get back to the internet, that will forward the request to our own Wi-Fi network, and that will be forwarded to us. So that's how it is going to follow a flow chart, you can say. So the private IPs are used whenever you are talking internally or in a private network, and the public IP will be utilized whenever you are connected to the internet sending some data to the outside network. Okay, now here this example actually means is, there is a computer for which the private IP is .77. There is another computer in the same network, okay, same network, just focus on that part, that is having a IP of .74. Okay, so because I told you that in the same private network both machines can't have the same IP, so that's why the last number is changing a little bit. So that's how these machines are there in the private network. But if both of these machines wants to connect to the internet, okay, both of these are going to be using the same public IP address. Okay, now why both of these machines are using the same public IP address? Because I told you that in the whole world these many IP addresses are only available for, as an like total number of IPs are these many only, and out of these many only few, like only a limited number of public IPs are available. Okay, so that's why to reduce the count, like within a private network a single public IP would be assigned, so that all the machines from that private network would be using the same public IP to get connected to the internet. So I will try to show you how, what it means. I will remove this part. So right now we have two machines. Okay, then we have our Wi-Fi, just a moment, then we have our Wi-Fi, then we have our internet. Okay, and in between I will mention it something. This is going to be our ISP or internet service provider who is providing internet to us. So these are like this. So now this is one machine, this is having this IP. Okay, so I will put it right here. The another one is having an IP of I guess 73, 74. So this is the different one. This is our Wi-Fi now, and Wi-Fi is all the wires and everything is connected to the main ISP or internet provider, whoever it is. It could be it could belong to any company, and that ISP is actually connecting us to the internet. Okay, and now suppose there is a on the internet there is a website. Websites are also on machines or on workstations, you can say, on servers only. So those are also going to be having a particular IP address always. So suppose this is google.com. Okay, this is a website that is hosted on a on the internet. Okay, that is connected to the internet. This is connected to the internet, and it is also going to have an IP actually, because it's running on a machine only. Okay, so suppose we are just assuming that it may have a IP address like this, 10 dot 12 dot 14 dot, it is, I'm just assuming it, but it is having a public IP address. Now whenever this dot 77 machine trying to communicate with dot 74, okay, it is going to be within the private network only. Okay, I will mark it down for better understanding. So it will be within this network only. Data will go to Wi-Fi, from Wi-Fi to this machine. So that's what it is going to follow. So yeah, so whenever a machine from the private network only is trying to move some data to another machine in the same private network, it will be only going through the Wi-Fi only. Okay, so this network will be used only. But now suppose this particular machine wants to access google.com on its browser. In that case, if you want to access it, what route we are going to follow? We are going to send the request to Wi-Fi. Wi-Fi will send it to your internet service provider. Internet service provider will move that request to the internet. There on the internet there will be multiple routers and everything that is going to forward our request to the server or machine of google.com. Now google.com is going to respond with the website or the page of google.com. It is going to return to the internet, and whatever path we took earlier, it is going to follow the same path to return that data back to us. So that is the procedure. But now see, whenever we were talking internally, these were using their private IPs, but now when it asks for the google.com page, it is using internet. So whenever you are using internet, ISP is going to provide a unique IP address to your whole private network. So what it means is, here we can see that this IP address, okay. So this ISP, what it did is it assigned this particular IP address to our whole Wi-Fi, okay. So this is how it is. So now whenever we are sending, like even if this particular machine trying to access google.com, okay, our public IP would remain this one only, okay. Also, even if this machine tries to access google.com, it will be using this public IP address only, okay. So if on google.com server, if we check from where the request is coming, google.com will understand that it is coming from this public IP. It is not going to know that it is coming from 192.168.1.77 or this one, okay, because these are private IP addresses. It will only know that it is coming from public IP address. Now this Wi-Fi would all obviously know from which machine it came from. Otherwise, if it doesn't know, how is it going to respond with the google.com page to whichever machine requested for it? Okay, so this Wi-Fi would definitely know which machine requested for google.com, okay. But for google.com, it came directly from this public IP address only, okay, that is assigned to us by our internet service provider. So all the private IP, all the private machines within a private network would be using the same public IP, okay. And this is implemented because we have a limited public IPs available, okay, that internet providers can assign to different people. So that's why it is implemented this way. So yeah, now this is what the IPs are, okay, to identify machines in a network only. But now we talked about that number of IPs that are available is 4.29 billion, right? We calculated here in IPv4, okay. But to get out of that restriction, later on we got introduced with IPv6, okay, and it introduced around 2 to the power 128 IP addresses, means at 340 trillion plus IP addresses, okay. So it is nowadays, it is also used, but not everywhere. But it will be used for sure in future everywhere, just to get rid of that restriction of IPv4, that we have only limited IPs. So the same IPv4 can be denoted like this in IPv6, okay. How it is denoted, how is it converted this way, we'll be discussing later on. But the same IP can be denoted in IPv6 as well, okay. Now let's talk about MAC addresses. MAC stands for media access control, okay. And on every laptop, every computer, every mobile phone, we have a motherboard. I'm not going to go into what motherboard is, but it's part of a physical part of every device, okay. And on
Yeah,
that there
and
is,
sorry to interrupt, just one small question here. So, MAC address is basically, as you said, like a chip. Is it like a chip, right? So, for every physical device, we will be having one address which is representing those devices. So, that is MAC address, right?
yeah. So Yeah, that is correct. So on every device there is a motherboard. On that motherboard there is a network interface chip card actually. On that chip card, a MAC address is assigned. Okay, and it looks something like this. Okay, it is of six different sectors, and first three sections are going to denote which is the vendor who made that chip. Okay, so if you look at it, you would be like, if you find out your MAC address, you would be able to identify which manufacturer made that particular laptop or things like that.
Like
Okay,
Dell or HP.
correct, correct, yeah, so like that. And the rest of the three sections would be unique address for that network chip. Okay, and conceptually all these MAC addresses would be unique all over the world actually. Okay, so the one MAC address can't be assigned to another device. Okay, anyhow, but there are some ways that can be used to spoof or like to change your MAC address temporarily. It can't be changed permanently. It can be changed temporarily only. Now why do, like, it's called as MAC spoofing actually. I'll remove this part. It is called MAC spoofing. Why is it used? Sometimes I'm not sure if you guys are aware of this particular thing, but there is a protection actually uh, on Wi-Fi's or internal or private networks where you are connected through LAN cables. Okay, so there is a concept of MAC filtering. Okay, what it means is, or a better example would be, you go to a hotel and you pay, and then you get to your room, and there what happens, that you get connected to the Wi-Fi and you are able to access the Wi-Fi and everything. Now, now what happens, that another person comes in but he didn't pay, but he can see that Wi-Fi is available, but he is not able to, even if he knows the password, he is not able to access the internet, means he is not able to access google.com and things like that. Now why is that? Because there is a protection of MAC filtering in the backend. So what it does is, uh, for every device whatever MAC address is there, the hotel or some admin guy, they what they can do, they can put only specific MAC addresses in their Wi-Fi configuration, that if a machine or a mobile is having that particular MAC address only, then only they will be allowed to access the internet. Like, then only the Wi-Fi is going to forward your request to the internet. Otherwise, It's not going to do that. So even if some person is connected to the Wi-Fi, still he is not able to access the internet. It's because there is a MAC filtering, and in that MAC filtering list, a list of MAC addresses are there, which are the only ones who are allowed to access the internet. Okay, so that is the case. Now there is a practical example here as well, given that there is a hotel Wi-Fi and you didn't pay for it, but one person paid for it, and uh, this just a moment. Yeah, so Alice packets are going, or like Alice is able to access the internet, but this guy Bob is not able to access. So why is that? So let's see if we can see that. So right now this is Alice. Okay, and let me zoom out a little bit. This is TryHackMe's website. This is router, and this is our Alice machine, and it is sending, like, it is sending different messages to the website, or like sending different requests to the website. These are going through the router. Why is that? Because Alice paid for it, and on this router this particular MAC address has been whitelisted, means it is allowed to send requests. Okay, now what if I try to send the same request from this Bob's computer? If I try to send it, see, this package goes and it goes into the dustbin. It's just a graphical representation, but what it actually means is router is going to drop that request. It is not going to forward it to TryHackMe, because this Bob guy didn't pay for the internet. So if I try to send it like multiple packets, all these packets are going to be sent into the dustbin, or like will be dropped. Okay, but if I try to if Alice is sending these packets, these are going through. Now let's see if we can change this MAC address of Bob's MAC address to Alice's MAC address. Let's copy this. Let's see if we are allowed to change it. Yeah, we are allowed to change it. Now see if we have changed it to the LIC's MAC address, and now if I try to send the request, you can see it is being sent to the website and we got a flag. This flag we had to submit here somewhere in one of the answers of questions, okay, to complete that question. So that's what it is. I hope it is clear. Parveen, any doubt from your side?
No, Himmat. Uh,
Okay. Now we still got some time, so we'll be quickly discussing about the ping uh, feature as well. So it is like normally it it uses ICMP packets. Okay, ICMP stands for Internet Control Message Protocol. Okay, so whenever you use ping to check whether a website is accessible or a particular IP address of a machine is accessible from your computer or not, it is sending ICMP packets. Okay, and it can be also, it also shows you what is the performance of your network. Okay, for example, I will show you from my, if you, it comes inbuilt with your Windows and Linux operating systems as well. So same syntax is there. If I right now, because I am connected to the internet, right, uh, how you can verify whether you are connected to the internet or not, what you can do, you can use ping space any internet website that is on the internet. So we have google.com, right? So if you press enter, it is going to send different ICMP packets. So right now it sent four ICMP packets. Okay, you can see there are four ICMP packets sent. The response also you got for all of those four packets. That's why there is 0% loss. Okay, so all the four packets got a response, so that's why there is 0% loss. And here the time that you see, right, 5 milliseconds, that is what it is taking to send the message to that particular server. Okay, so 5 millisecond, 5 millisecond, 6 millisecond, 7 millisecond. Now if your internet is slow, okay, this time is going to increase. Okay, because it is not going to be able to send a packet that quick because your internet is not fast enough, like it is not able to forward your packets that quickly. That's why this time is going to be high. For example, if I ping some other website, facebook.com, so for that as well it is almost same as of now. But if your internet is not that good, it is definitely going to increase the time. Okay, right now I'm using 50 mbps plan, that's why it's a bit less. But if you are using a less speed plan like 10 mbps, something like that, that timer is going to increase, and that means that that much time it is taking to send the request and bring the response back. So here as well it is explaining the same thing, that different packets are sent. This syntax is from this is from Linux machine actually, because on Linux machine uh, unlimited packets will be sent. On Windows by default it only sends four packets, so one, two, three, four. And on Linux machine it sends a unlimited number of packets actually. Let's see if we can, I can show it to you. So I will just quickly run my Kali machine, Kali Linux machine, and okay, so it's up. So let's see if we try to follow the same thing from our Kali machine. I will ping google.com, and here it is going to keep sending that request. And here as you can see, time it is mentioning here are a bit higher than what we were getting on Windows, because Windows was directly sending the messages. Here what this Kali machine is doing, it is running on VirtualBox, it is sending it to your Windows first, and then Windows is forwarding to Wi-Fi, and that's why it's a bit high. So, and it will keep sending these messages until you press Control C to stop it. Okay, so that's how it is. On Windows it only sends by default four messages. You can increase it with the by giving a different argument or a flags that we discussed in past, but by default it only sends four packets. Okay, and yeah, and here on Linux you can see that it sent these many packets within that this much amount of milliseconds. So it's around, I guess, 28 seconds you can say, because 1000 milliseconds means 1 second. So yeah, 28 seconds you can say it took to send these many uh, message packets to the google.com. Okay, now it is also one of the to solve one of the questions. It is asking to ping this particular IP address once we are connected to this particular lab.
So now that the website has opened and we are supposed to ping this particular IP, let's ping it and see whether we receive the flag or not. So let me send the request. So it will send around 4 ping requests, and at the end we will receive our flag. Once you submit this flag here in this questions answer, you should be able to complete it.
That's all for today. Thanks everyone.